Hello all. Now let us look into the power series solution of the second order linear differential equation. So in the general second order, so we are going to look at first homogeneous linear equations. So general second order homogeneous linear equation is of the form y double dash plus p of x y dash plus q of x y equal to 0. And here we have the coefficient functions p of x and q of x. Now the points where the function p of x and q of x are analytic, they are called the ordinary points, and the points where these functions fail to be analytic are called as the singular points. So when we find the power series expansion, so we will be finding the power series expansion about the point x0 where x0 is an ordinary point. So the points where the functions p and q are analytic, so they are called the ordinary points, and points where p and q fails to be analytic, so they are called as the singular points in this case. So we will be finding the power series expansion about x0 where x0 is an ordinary singular, where x0 is an ordinary point. So let us look at an example of finding the power series solution of a second order linear differential equation. So find the general solution of y double dash plus y equal to 0. So here you have p of x equal to 0 and q of x is equal to 1. So these functions are analytic for all x. So therefore all points are ordinary points. So let us take the simpler form of the power series. So that is summation a n x power n. So let y equal to summation a n x raised to n be the solution. So y dash will be equal to, so y will be a0 plus a1x plus a2x square plus a3x cube plus etc. an x power n, and y dash will be a1 plus 2a2x plus 3a3 x square plus etc. n x raised to n minus 1 plus etc. and y double dash will be a2 plus 2 into 3 a3x plus the next one will be 3 into 4 a4x square plus etc. So here you will have n into n minus 1 an x raised to n minus 2 plus etc. So now equating the coefficients. So y double dash plus y equal to 0. So our equation will be okay. So let us write the equation of y double dash plus y. So that is going to be a0 plus 2a2 plus a1 plus 2 into 3 a3x plus a2 plus 3 into 4 a4 x square plus etc. X raised to n in the coefficient an plus here you will have n plus 2. So n plus 2 into n plus 2 minus 1 n plus 1 a n plus 2. So that will be the coefficient of x power n. So this will be equal to 0. So equating to 0 you will get, so 2a2 will be equal to minus a0, so that implies a2 is equal to minus a0 by 2. Then 2 into 3 a3 plus a1 is equal to 0, so a3 will be minus a1 by 3 factorial. Okay. So again 3 into 4 a4 plus a2 is equal to 0, so that implies a4 will be minus a2 by 3 into 4, so that will be minus a2 ന്റെ value a0 by 2 1 by 3 into 4, so that is minus a0 by 4 factorial. And again next term will be 4 into 5 a5 plus a3 equal to 0. So we will get a5 equal to minus a3 by 5 into 4. So that will be minus 1 by 5 into 4. a3 is minus a1 by 3 factorial. So that is a1 by 5 factorial. And continuing this way, we will get rest of the coefficients. So therefore now we can write y. So y will be a0 plus a1x plus a2 into placing minus a0 by, you can write it as 2 factorial x square. Then a3 will be minus a1 by 3 factorial x cube. Then okay, this is minus a0 by 2 plus a0 by 4 factorial plus a0 by 4 factorial x raised to 4, then plus a1 by 5 factorial x raised to 5 plus extra. So taking out a0 and a1 outside, so you will get, so y will be a0 into 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial. Next term will be minus x power 6 by 6 factorial. Pattern x a1 in the coefficient we will get x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x. So this will be a0. Now this is the series of cos x and a1 sin x. So therefore the two linearly independent solutions will be cos x and sin x. So this is going to be the general solution. Now let us look into the second example. Second is, so we will solve the Legender's equation. So Legender's equation is 1 minus x square y double dash minus 2x y dash plus p into p plus 1y equal to 0, where p is a constant. So we will look at the power series solution of the Legender's equation. So here when you convert to the general form, so p of x will be minus 2x by 1 minus x square, and q of x is p into p plus 1 by 1 minus x square. Now p and q, you can see that both are analytic at the origin. So p and q are analytic at the origin. So we'll find a series solution of the form. So we'll find a solution of the form y equal to summation n x bar n. So let us find the derivatives and then find the solution. So let y equal to summation n equal to 0 to infinity a n x bar n be the solution. Then y dash equal to summation n equal to 1 to infinity n a n x raised to n minus 1. So this will be equal to summation n equal to 0 to infinity n plus 1 a n plus 1 x raised to n, and y double dash will be summation. Again, if you differentiate this, that is summation n equal to 2 to infinity n into n minus 1 a n x raised to n minus 2. So if you start with 0 to infinity, you will get summation n equal to 0 to infinity. അപ്പോൾ നമുക്ക് ഇവിടെ n ന്റെ പ്ലേസിലെല്ലാം n plus 2 വരും. So n plus 2 into n plus 1 x raised to n വരും. So and then you have a n plus 2 x raised to n. So that is the series for y double dash starting with 0 to infinity. So now we have the products x square y double dash is there. So minus x square y double dash under, then minus 2x y dash, and these are the terms we need, and p into p plus 1 y. So minus x square y double dash will be summation minus, so that is summation n equal to 0 to infinity minus n plus 2 into n plus 1 a n plus 2 x raised to n plus 2 varum. So if we want x raised to n to be the power, so the series will be rewritten in the form minus n into n minus 1 a n x raised to n. So there n will vary from 2 to infinity. Okay. So now let us look at the series for minus 2x y dash. So that will be you have y dash here. Okay. Let us multiply in the first one itself. For minus 2x summation n equal to 1 to infinity n a n x raised to n minus 1. So that will be summation n equal to 1 to infinity minus 2n a n x bar n. Now we have the series in the power of x raised to n, and p into p plus 1 y, that will be summation p into p plus 1, that is constant. So you will get a n x raised to n. Now let us substitute these terms into the equation. Okay. So our equation is 1 minus x square. Okay. So let me write it as y double dash minus x square y double dash minus 2x y dash plus p into p plus 1 y equal to 0, and let us substitute these series. So that will be summation n plus 1 into n plus 2 a n plus 2 x raised to n. അപ്പോൾ ഞാൻ എടുത്തിരിക്കുന്നതിലെല്ലാം x raised to n ന്റെ കോഎഫിഷ്യന്റ് വരുന്ന പോലെയാണ് സീരീസ് എടുത്തിരിക്കുന്നത്. ഓക്കെ.